Hello everyone, this is Jared and Patrick, and this is going to be our database final project. The title of our company is Tactical Strike Shadow Ops, which is a video game company. So starting off, this project involves developing a relational database for Tactical Strike, which is a first-person shooter game that emphasizes strategic play and teamwork. The database will manage complex data such as player profiles, game statistics, in-game transactions, which aims to provide a scalable, efficient, and secure system to enhance the game's functionality and player engagement. This robust backend system will support a multi-layered game environment with real-time analytics and extensive storage needs, which accommodates features such as a virtual economy, varied game modes, and a personalized player experience. So, little overview of our presentation. We're going to go over our part 1 deliverables, which is our business logic and rules, our information flow diagram, and our data model. And we're also going to go over our part 2 deliverables, which is our EGR diagram, our SQL scripts, which create our database and populate the database with data. So going over the business logic, we have 5 main points. The first is unique constraints, which is basically to ensure data integrity. There are various unique constraints on usernames and email addresses in the player table, which prevents duplicate entries, which could lead to player identification issues and data integrity problems. The next point is matchmaking logic. So the database incorporates a dynamic matchmaking system that pairs players based on skill level and reduces wait times by prioritizing matches for players with fewer than 50 games and using a balance of win-loss ratios and random selection for fairness. The next point is game difficulty adjustments. There's a procedure for adjusting the prices of items based on average player feedback scores. If the average feedback score for an item is below 3, the item is reduced by 10%. Reflecting on a dynamic adjustment system that aims to balance the game's difficulty and player satisfaction. Our next point is data integrity and referential integrity. So constraints and foreign keys are used extensively within our system to maintain consistency and the accuracy of data across the various tables. A few examples would be like game sessions, player statistics, player items, and feedback. And then our last main point is going to be performance optimization. So the database design includes indexing strategies to optimize query performance, particularly for player authentication processes and game session management. This ensures that the efficient data retrieval and the system in general is responsive, which is critical for maintaining a smooth game experience. So next we're going to go over our information flow diagram. There's 2 main parts. So you have the user interaction. One route it can go is to the core game system, which includes things like logging into your account, playing the actual game, and then purchasing like DLC and stuff like that. And then going from core game systems, you can branch off into account management. So this can be things like profile management, transactions that you've already purchased, and then overall gameplay. And then there's also a gameplay branch, which holds things like game sessions and statistics data. And then you have overall economics, which deals with things like shopping, purchasing items, and like rewards that you receive. Another branch you can go to for the user interactions would be to go down to support and feedback. So if something is going wrong with the game, you'd submit a ticket, which then moves on to the analytics and reportings. So this allows our company to kind of go over like common issues and then go from there. And then we basically take what we learned from that branch and go down to the content management. So this is where we decide to do things like updates to make the game better. And then we deploy those updates, which eventually leads back to the user interactions, which can either go back to the core game systems or back to support and feedback if they run into any more problems post-update. Moving on to our data model in our EER diagram. We're going to start off with the users table since that's kind of where most tables stem from. Each user has a unique ID, a username, an email, a password, and an account. We then move on to our items table, which items are defined by an ID. They have a name, a description, a type, and a price. We have player items, and this is a relationship entity that links users to their items and how much items they have. Game statistics is our next table, and this contains each player's gaming stats, so things like kills, death, win-loss ratio, and games played. Next, we have player profiles, and these profiles hold on to details such as a display name, an avatar, a rank, and experience. Game session is the next table, and this records session IDs, player IDs for those sessions, start and end times, and session statuses. Next is transactions, and these log transactions with details of the user, so things like the items that they bought, how many, and the date of the transaction. Next, we have support tickets, and these track the support tickets with descriptions and their related stats. Team members shows which users are in which teams, what their roles are, and when they joined. The teams table has the team's ID, the name, and the creation date. Content updates shows details about content updates, which includes titles and release dates. And then feedback has the entries with text and submissions dates. The relationship between these tables, so users are centrally related to many different entities. They open support tickets, can be part of team members, they have player profiles, create transactions, submit feedback, and are integral to game statistics. Items are connected to transactions, showing what was bought, and to player items, showing which user possesses. Game session relates to two users, presumably to record a multiplayer session. Teams are made up of team members who are also users. Player profiles, game statistics, support tickets, transactions, and feedback all directly relate back to users, indicating that these entities are tied to specific user activities or attributes on the platform. And then content update stands alone without any direct relations because it's updated independently of the user interactions. So, moving on. And then now I'm going to show you the base creation script that we have for MySQL. So I'll go ahead and open up the program. So here basically we start off by creating our database, and then we create each table. So starting off with user, we have our primary key, which is going to be an integer, the username, email, password, which are all varchars, and then date created, which of course is going to be a timestamp. And the majority of the following tables follow a similar format. So they'll have their primary key, so player profile has profile ID, and then we have user ID, which acts as a foreign key and references back to the user table. And then, kind of like I said earlier, this is going to follow suit with the next table. So game statistics has its stat ID primary key, but the user ID is going to point to the user ID from the user table, and then so on and so forth. And then we also have instances where things like transactions will reference user ID from users, but also item ID from the items table. So items and users pretty much hold the most weight when it comes to relationships. Alrighty. And then now we're going to show you the data insertion script. So this is going to be the script that we use to fill our database with data. So as you can see here, we use the insert statement, and we start off by inserting our users. And this will include things like their user ID, username, email, password hash, and date created values. So here are a couple examples. So J Garcia is the user ID or the username. Email is going to be their email. And then we have their password hash and then the date created. Moving on to the next table, we have our player profiles. And this is going to have things like their profile ID, what their user ID was, display name, avatar, and then so on and so forth. And then we have their game statistics, which includes like total kills, total deaths, so things we've already went over. And then, yeah, so on and so forth. And then you can see here that this data is populated in our database. So if I go to one of the tables, such as users, and I want to select the top 1,000 rows, I can see all of the users we inserted here in our database. And I can do the same thing with, let's say, items. And we can see the items added in.